Hi, this is Rob. I'm going to show you how to do the exercises that go along with the Math Antics video lesson, Basic Inequalities. Are you ready? Let's go. For our first problem, we're told in each circle to draw the inequality sign that correctly compares the two numbers. And so we have the numbers 10 and 3 being compared. And so we need to draw the inequality sign, the greater than or lesser than sign, that correctly compares the two numbers. So 10 is obviously greater than 3, and so we need to draw the correct sign. And remember, one way to remember it is that the bigger open end is like an alligator's mouth open in the direction of the bigger number because it wants to eat the larger number. So we show the greater than sign. You draw it in this direction. The bigger open end faces the bigger or greater number, and the smaller end faces the smaller or lesser number. And then here we have the numbers 15 and 20, and we need to draw the correct inequality sign for these two. And 15 is less than 20, it's smaller than 20. So the small end needs to point to the 15. So we show the lesser than sign. The small end points to the 15, which is smaller, and the larger open end points to the 20, which is bigger or greater. For problem 2, we're told in each circle, draw the inequality sign that correctly compares the two numbers. And here we have the numbers 7 and 8, and 7 is smaller than 8. They're very similar in size, but 7 is smaller or lesser than. So we show the lesser than sign. And then 1 and 0. 1 is greater than 0. It's larger than 0. So we show the greater than sign. And see, once again, the larger open end is facing the larger or greater number. Larger open end, larger, greater number. For problem 3, we're supposed to graph this inequality on the number line. And we have n is greater than 6, and we have this number line right here. So we need to show all of the answers that satisfy this inequality. N is greater than 6. So any number that is greater than 6, or to the right of the 6 on the number line, will be true for this inequality. And since it's greater than, not greater than or equal to, that means that 6 itself isn't included because 6 is not greater than 6. And so we draw an open circle or an open dot instead of a filled in dot. And then we draw a line over the number line. You might have to draw it a little thicker if your pencil is the same size as the line. And then draw an arrow to show that it keeps on going, that any number to the right of the 6 is included in this graph. It's true for this inequality, that n is greater than 6. For problem 4, we're supposed to graph this inequality on the number line, and we're given n is less than or equal to 5. So this means that any number that's less than 5, like 2, 3, or 4, is satisfies this, but also any number that is equal to 5, which is 5. So to show that it includes the 5, we draw a filled in dot. So that shows that 5 is part of the graph, the answer set that satisfies this inequality. And then any number less than 5, and so that is going to be anything to the left of 5. So we fill in this. And since it stops at 0 on this number line, you could just stop right there at the 0. Or you could draw an arrow pointing this way, showing that even negative numbers satisfy this inequality. For problem 5, we're told to graph this compound inequality on the number line. And we have this here, which it seems like you should read it, 2 is less than n, which is less than 8. But it's a little easier to read if you say n is greater than 2 and less than 8. Even though this is technically the less than sign, since we're reading it right here in the middle and reading it towards the left, the open end comes first in the direction we're reading from. So we say n is greater than 2 and n is less than 8. These aren't the greater than or equal to or less than or equal to signs. So that means that the 2 and the 8 are not included in this compound inequality. So let's start by doing an open circle or an unfilled dot on the 2 and the 8. And then we draw a line connecting them, showing that any of the numbers in between those two numbers are correct. They satisfy this compound inequality. For problem 6, we're supposed to graph this compound inequality on the number line, and we're given n is greater than 0 and less than or equal to 40. So for the 0, it's not the or equal to type sign, it's just the, well, reading it this direction, it's the less than sign, but reading it from the n to the left, it's the n is greater than 0. But we will do an open dot for that. And then on the 40, we have less than or equal to. So for the 40, we do a filled in dot to show that the 40 is included in the set of answers that satisfies this compound inequality. And then to show that all of the numbers in between the two are included, we draw a line between our open circle and our filled in circle. And so that's the graph of n is greater than 0 and less than or equal to 40. For problem 7, we're supposed to write the inequality that is represented on the graph. And we're given this graph here that goes from 0 to 35, and we have a filled in dot on the 25, and then the line goes to the left of the 25. So anything that is less than or equal to 25 will satisfy what is the inequality that this graph represents. So we'll use the letter n like we've been using. And then since it's to the line is going to the left of this, it's going to be less than, and since the circle is filled in, less than or equal to, and then the number here where the dot is 25. So this graph represents the inequality n is less than or equal to 25. For problem 8, we're supposed to write the inequality that is represented on the graph. And we're given this graph here that goes from 0 to 70. And then we have an open circle, an unfilled circle on 30. And the line goes to the right of 30. So anything greater than 30. So we'll go n is greater than, and we don't do the or equal to because it's a open circle. So that means the 30 is not included. Only numbers that are greater than 30. So this graph represents the inequality n is greater than 30. For problem 9, we're supposed to write the compound inequality that's represented on the graph. And we're given this number line here, goes from 0 to 10. And this graph, we have a dot on 5 and a dot on 9 and a line between them. And both of them are filled in dots. So that means that it's going to be the greater than or equal to or less than or equal to. And so on the lesser side, we have 5. And then n is going to be in between the 5 and the 9. So we have 5 here and 9 here. The correct answers are going to be greater than or equal to the 5. But we don't remember we have the n on the right-hand side of the 5. We're reading it from the n to the left. So the n is greater than or equal to 5. But we write it in this direction because we're kind of reading it backwards. So 5 is less than or equal to n, or we could say n is greater than or equal to 5. For the 9, the correct answers are going to be less than or equal to the 9. So we write that. The same symbol, but we say it differently because this one we're reading backwards. N is greater than or equal to 5 and less than or equal to 9. And that is the compound inequality represented by this graph. For problem 10, we're told to write the compound inequality that's represented on the graph. And we're given this number line here from 0 to 35. And then this graph here, we have a filled in dot on the 5. And then it goes, there's a line from the 5 to the 15. And on the 15, it's an unfilled dot. We're going to start with the 5. So our correct answers, the part of this line here is greater than 5. Well, greater than or equal to 5 because the 5 is filled in. But remember, we're writing this backwards. N is greater than 5, but we write it this way. N is greater than, has the big opening here towards the N, is greater than or equal to 5. And N is less than 15. And we don't need the or equal to because it's an open circle here. 15. So this compound inequality is written as n is greater than or equal to 5 and less than 15.